Hey, welcome everyone. I have today with me Austin Muthar from R3 Corda. Hi, Austin.
Hi, Rosie. Thanks for having me here.
Awesome. So, tell me about yourself a little bit.
Sure. Yeah. So I'm a solutions engineer at R3. So from a developer from my past life, so kind of grew up in the engineering side of the house, but really ended up on the client-facing side of things. So really work a lot with clients on a day-to-day basis and really kind of solve problems in the production space.
Awesome. And you know what the reasons I want to talk to you about today was predominantly Corda. This from a developer technical standpoint. I think this is one area where I think it would be good to have someone like you talk about in detail, like where the Corda is heading, what it is about, developers who want to go and start working on it. So we're gonna have all that, but maybe you can just start with some of the goals of Corda. I played with it a little bit in 2016, 2017, but for people who have no idea what it is, how do you want to introduce Corda to them?
2016. You're back from the original days.
Yeah. I try to pick it up, and
Yeah.
I do want to talk to you a little bit about one of the things that come up very early on is the DLT versus the blockchain and the whole thing. So I do want to go to that in a bit, but let's just
Sure.
talk a little bit about what R3 Corda is, why you wanted to use it, what's the purpose of it.
Yeah, sounds good. And it is, we actually like to cover that in a lot of this stuff, and we kind of talk about why Corda even exists, right? Because there's a lot of blockchain solutions out there. And when Corda was founded back in 2016, it was actually to take a very different approach to what existed, right? Because a lot of blockchain came to be out of coins, right? Cryptocurrency, Bitcoin, Ethereum, all that stuff where there's these public massive chains. But the founders of R3 and Corda really realized that there's a different problem which needs to be solved where blockchain is applicable, and that really is in the enterprise space. And if you're going to work in the enterprise space, you actually need to be looking at solving very different kinds of problems, because all of a sudden a completely public, one chain only, and completely open chain is not going to work for these regulated and compliant industries. And so what we did is that we established Corda, which at the time there really wasn't anything in the way of these private blockchains like this, and to specifically solve the compliance, regulation, auditing needs of these large companies. And so at a time, and so what this meant is that all of a sudden we actually have a very different mode here, and that's really grown out of that. And so what we have is called a private permission ledger, whereas instead of a single massive global chain, we actually have lots of smaller networks which are doing lots of smaller chains, which can potentially even end, as opposed to dealing with one large massive blockchain. What we end up with is that there's actually a little bit of a controversy about this back in the day, which is that our Corda is not a blockchain, which kind of technically it's not. Yeah,
that was about to say. This is the probably when I started looking into it, it was the one thing, and I think I do think to a degree there's a true sort of like a way of looking into it. But do you want to talk about it, like where you draw the boundary between a DLT, and the blockchain?
Yeah. So it's actually, at least in my mind, it's a bit of a clear boundary, which is that in Corda, we're not dealing with blocks. We're not mining blocks of transactions. In fact, each transaction is on a case-by-case basis, really. So what we have is actually a chain of transactions as opposed to a chain of blocks of transactions. So we're connecting one transaction specific to another transaction, and the only people involved in that who actually can see those particular transactions are the ones who were originally involved. So it's really information distributed on a need-to-know basis.
Okay, so depending on the participants of this, DLT, they are the only one who are going to be involved in the transaction. Is it like between, and I don't know if you want to go in detail right away, but probably going to touch base later, but what would be good to understand is if the two parties doing transactions among themselves, would the other participants will be aware of it, or maybe just aware of the metadata, or they're not, they're completely oblivious to it?
Completely oblivious. And that's a really important thing. Any existence of any information is considered a leak, even if that's hashed information and it's completely unrecoverable. Simply the existence of a transaction is too much for the client base that we work with.
Okay, got it. So just the leakage of the metadata is also considered sort of like not good for the model that you guys
Correct.
are following.
And so what we've ended up with, and I think we will actually get into this a little bit, is we've ended up in a peer-to-peer network, right? So you will work directly in a message-by-message basis with all of your counterparties to actually put that transaction onto the ledger.
Okay, another thing very quick, and this is for the perception and versus the reality kind of a questions. I know that the R3 Corda stem out of the finance. Like, I mean, that's the core sort of like the history or the DNA. Is that even true today? Like, I mean, can this be used for other challenges? Like where it is?
Yeah, we get this a lot because our original rounds of funding all came from a membership core of banks, and so we ended up really tagged with the financial services industry, and really, as it turned out, we really discovered this, I think, probably within the last year and a half. There's actually a lot of industries out there that need this, and as it so happens, Corda is designed in a very flexible way such that we're actually meeting the needs of many other industries. So actually our most popular up and coming industry right now is the insurance industry. So I do a lot of work with those insurance bases and really helping them solve things like first notice of loss, reinsurance, proof of identity, et cetera, et cetera, et cetera. And we're also seeing additional use cases in supply chain, trade finance, real estate, energy, et cetera, medical. It goes on and on. So really anything which has an asset or anything that is regulated and compliant, there's a lot of value in putting things on a ledger.
All right, so let's do this. I think that's a little bit of like the landscape introduction. Now let's jump into like a little more technical. So, and we can assume that the people who are listening to this or watching this is like they understand databases, the transaction distributed systems, because it's sort of like software engineers are pretty much exposed to that. But let's say they're not fully onboarded with DLT or blockchain. So for them, how would you introduce them to the Corda?
Yeah, so from that perspective, with the technical backing, really what we're looking at is a basic addition to the middle tier of a standard 3-tier architecture. So Corda is a piece of middleware that sits in your data center and applies signing and handles the messaging between all the counterparties to record these transactions, not to some chain somewhere, but it's actually going into a standard SQL database. So for example, Corda is JDBC compliant, which means that you can stand up a Microsoft SQL server and you'll be saving those transactions direct to the standard database that you're used to. And in addition, you also are using the JVM, so we're using Java. So these are standard tools, right? We didn't invent any new toolkits. And so what the benefit here is that we can go to these enterprise clients and say that you don't actually have to make any new tools, you don't have to train up any new people, you can plug into your existing systems and get the value of blockchain added on top of that.
Awesome. So, all right, so I think this is a good sort of like a starting point for us now. So what should I be, like what should I know on a day one if I wanted to just dig into like, hey, I understand the high level, I want to get started, maybe talk about the architecture, like what the basic features are.
Yeah, so I think maybe this is a good chance to kind of move forward and actually just walk through at least a couple slides. There's semi-technical slides and cover just some of the basics of that. I think for folks, if you're interested, this is a little bit of our history. This is also available online, and just we're about 4 or 5 years old now, so relatively young as far as the company goes. And you can see, I think the most important thing here from a development side is that we have been open source since 2016, and I think we may even talk a little bit more about that, but that's the plan forever, right? Corda will forever be an open source project. And then recently we've launched the enterprise version, which really is the paid for version around Corda open source.
So maybe we can go through some of the key concepts.
Yeah, that sounds good. So I do this a lot. So one of the things I do is training here with Corda. And so we often do a lot of teaching, right? As we talk about these things. And there's a little bit of a vocabulary lesson that comes with Corda and really with blockchain in general, right? These are a lot of new concepts. So it's really important to discuss with people, hey, when I say these words, this is kind of what we're getting at. So Razi, you and I talked a bit about, privacy, and really if there's one core thing about Corda that's important to talk to people about, it is privacy, right? This is the number one feature beyond security, of course, which is always number one. Privacy is the number one thing. And we talked about how really it's peer-to-peer basis. And so what you can see here in this slide is you'll see these things called the Corda nodes. So the Corda nodes are effectively your virtual machine, which is running some Corda application. And that is what is representing the identity of someone on the Corda network. And that is transacting on their behalf to then record to the ledger the finalized transactions.
So these nodes are essentially, let's say there are 3 parties involved, mm-hmm. and there are counterparties. So they definitely want to do business together, but they don't trust each other. I believe so in the same way that within the organization the trust is. So they'll be running a VM with the Corda app. Is that a correct understanding?
Yeah.
And when they do the transaction between themselves, then how it will be like transparent that to other party that there was a transaction, just like they don't know about it. Like, do you provide that guarantee, or we don't have to do that?
Yeah, that's a great question. So it's right that you're really getting at the consensus, right? How do we drive consensus on this?
And because it's a big deal in a public blockchain, like essentially there's a make or break deal. So I'm just trying to understand, like in the permission world, how that works out with Corda.
Yeah, if you just give me a couple minutes here, I'll kind of build up to that. Yeah, which is a great question. This is actually, I mean, it's the hot topic of all of this, right? Is with all these systems, how do you drive consensus? So just a couple things to kind of build up towards that as we head that way. Just to get a view of the ledger, this is how we really represent these things, right? So if you have a network of 5 people, these are our standard actors: Alice, Bob, Carl, Demi, and Ed. Each of this is a Venn diagram, and the overlap in the Venn diagram is wherever transactions have taken place. So for example, we'll just put 9 transactions on here, right? And you can see that Alice and Bob have been transacting with 1 and 7. Bob has also been working with Carl on 6 and 5, but Alice is completely unaware of that, right? So Bob's ledger is actually different than Alice's ledger. So what that is to say is that each person has a different ledger than everyone else, because it's all about the peer-to-peer nature of the transactions. And if you've built out the rest of them, you can see that everyone has a slightly different view. Now, going into the key concepts themselves, the way that we represent this, right, and this is kind of getting into the technical lingo here, right? As soon as you start looking at a Corda application, you're going to start seeing a lot of these words come up. So states, going from left to right here, states are effectively the representation of data which is stored on the ledger. This is a POJO, right? It's a plain old Java object. There's nothing fancy about it. It's simply a class, and it has n number of fields for whatever it needs to represent, right? In this case, it's an IOU. So we have from, to, amount, due date, paid, penalty, right? None of that is Corda defined. This is all up to you, the application developer, to actually define what it is you're representing on top of a Corda application.
Awesome. And just to maybe clarify here, this is all running in the context of JVM.
Correct.
Okay, so that's the sort of like the bare minimum requirement to run Corda.
Yes, currently we are all in the JVM. That's the choice, because that's where enterprises are running their applications. Anytime, it's never been a point of concern where someone says, "Oh, well, we don't use the JVM in our data center," right? That's never a conversation we have to have.
Got it. So basically, yeah, because I would imagine, especially in finance, there's a good footprint of JVM already there, so it's an easier conversation probably.
Correct.
All right, so there's the state object, and then we have the transaction.
Exactly. So the transaction is actually how you create proposals to update the ledger. So in this case, there's 2 different states here. You have a state on the left and a state on the right. And just in a very similar way to, honestly, the way that Bitcoin works, right? You're actually consuming an input state to then produce a new output. And when I say consume, that basically means that you're actually using that, and each state can only be consumed once, to kind of get to hint at your consensus question here. So that state is consumed, and then we produce a new output, which is recorded on the ledger, and those 2 become linked, and therefore we have our chain, right? So this is how you're actually, so as, for example, as an IOU, let's say you start taking payments. Each time you take a payment, you'll create a new output state linked to the last one, and so on and so on and so on. So you might, for an IOU, if you make 30 payments over 12 times a year, that's 360 payments over the lifetime. 360 new states created. All
right. Now, a couple of questions right there, just to get a better understanding. Now, in this particular transaction that is happening from left, well, basically there's a state, and then there's a transaction, and there's a validation. Who is doing the validation here?
Yeah, so the validation, I think you actually said a key thing here just a few minutes ago, which is that people are doing business together, but they don't really trust each other. So validation is happening everywhere. The validation happens from the proposing party to make sure that they're creating a correct transaction. It happens from all the counterparties to make sure that they're not being tricked. And it also happens at the network level to ensure that we've solved the double spend, right? That there is no double spend of states. And I'll kind of dig deeper into that in just a moment. But we really do that through smart contracts. So just like every other blockchain out there, right, there is a concept of a contract, and that contract basically says this is what a valid global transaction looks like. And there's an important subtle distinction here, which is that in Ethereum, for example, your contract both does the validation and it does the declaration, like it's a command. This is what will happen with this transaction. But in Corda, it's pure validation and nothing else.
Okay, so basically the code inside the smart contract is for validation only. Is that correct understanding?
That's correct.
And the actual code that you want to like define as a behavior is somewhere else.
That's right. And it's actually in the last thing on here. It's in the flow. So we've kind of broken these things apart a little bit. And the flow is really the communication between all the different parties on the network. So it does a few things. So if you, Razi, want to propose an IOU to me, you can create a transaction in your flow, which creates the relevant state objects. And then you'll send them across for me to validate and sign off, and then send back to you. And that flow handles both the construction of the transaction as well as the exchange of messages between our two Corda nodes.
Okay. Now, one more question here regarding just the state. So after the consensus is done or the validation is done, where these like state objects persist? Is there like every single node or just selective nodes?
It's just the selected nodes, and that's the key piece there, right? So so for Razi, your node and my node, we would record the IOU, the IOU $10 for lunch, but really Alice and Bob, they won't ever see any of that. So just in our databases, we would record those states as a row in our database, and that's it.
Got it. Now, one of the things with the blockchain is that comes quite often in the public space is that the transparency. Like, I mean, you can go back and say, well, you did this, and this is approved, this is immutable. In this particular case, how do we get the similar sort of like features?
Yeah, so there's two things there to unpack. So for immutability, it was your second question. The immutability is achieved in the exact same way it is for the public chains, and that is through private public key pair cryptography, right? So we have each node, so you, Razi, and me, Austin, we each have a node, and that node actually has a private public key pair established with it, which is also its identity. So we have these public identities within the private network, and that we're using that to sign these transactions to make them immutable. So what's actually saved in our database isn't a plain record in English necessarily. It's actually the signed version of it, such that any changes to the state would then no longer match the signature, therefore something's been tampered with. Got
it. So that's basically sort of like the basis of how you can provide immutability in the network. Okay, so let's do this. So now we have this concept of state, transaction, validation, and flows. So combine this, now you can create an application, or you need more to understand to create like a basic Corda application.
That's it. That's actually it. These are the, from an application perspective, these are the four main concepts, and that's it. But there's a lot of depth to these, and I think it'd be good to even walk through an application and just kind of talk through some of these concepts in the context of a running basic sample application.
That would be great. So let's do this. It's a good time to jump into the demo, or do you want to talk something more?
Yeah, I think we'll keep rolling, because I think I do want to get to your consensus side of this too. And actually, I think we actually talked through this verbally here in terms of this is what a diagram for a flow really looks like. So if in this case of really it was Razi initiator, responder Austin, you're actually going to create this IOU and then sign it. And so this is all happening on your node. And then these arrows which go in between the different parties, which correspond to how the flows are orchestrating that peer-to-peer communication between the different nodes. And then on the far side, we're actually inspecting and verifying, right? Again, that's the contract, signing the full transaction, and then sending it back for complete validation from Alice before everything is finally committed to the ledger.
Got it. So just a quick walkthrough. So I will just play someone who don't know anything about this and learning for the first time. So Alice is initiating a transaction, basically. Is that correct?
Yes.
Okay, I get the data from internal system. That can be anything. Create the payment transaction, sign the transaction. So signing it with your private key, the Alice sign it with the private key. They send the transaction plus the signature, and the responder is Bob. So the transaction is sent to Bob. And Alice and Bob are basically can be like two different organizations, I believe. That's the idea.
In general, yes.
In general, yeah. So bank A, bank B, and then inspect and verify, sign the transaction. So this signature is happening with Bob's private key?
That's correct.
Okay.
So what we'll have is a transaction with two sets of private keys from all the participants. Therefore, if any one, that has to match both of their keys.
Awesome. And then you commit the transaction, and that really means that you're writing it onto the ledger.
Now this is actually, I will have to admit that this is actually slightly out of date. This commit actually hasn't happened quite yet, so it's a little bit out of order. So it'll actually send back to Alice at this point to do the rest of the inspection and verification. Because Alice also needs to make sure that Bob has signed the transaction, because she shouldn't commit anything unless Bob has immutably agreed to the transaction.
And we know that is Bob because Bob signed it with a private key.
Yes.
And we have a public key.
And we know his public key, and that's the key thing. Everyone's public key is known within the network.
And then you commit it, and they're sent. And on the top here, there is the input IOU. Okay, this is
this is actually the transaction which Bob is proposing. So he's consuming an input IOU to create a new representation of the output based upon some payment that Alice is making, or Alice is making some payment to Bob based upon this IOU, and that's what's actually getting verified and signed as a part of this flow.
All right. And the flow would be similar if there are more than one party. Let's say there is a Alice, Bob, maybe Andrea. It's like, there are three parties now. So it would be the similar flow, just like more participants.
Exactly. You'd have more rows in here. You'd have more communication between the nodes, but the principle would remain the same. Someone proposes a transaction, and all the counterparties involved will verify it and sign it accordingly.
Great. I think that clarified quite a bit.
Cool.
Just visually looking into it.
Yeah, it really helps a lot, these flow diagrams. And this is honestly, when I sit down with clients and new use cases, this is one of the first things we do, right, is walk me through the business use case, because we need to map the actual business to the technology. And this is a very common activity for us. Cool. And then finally, to answer your question, this is a lot of people's favorite topics here, is consensus as a service. And really what this is that we, like all blockchain problems or platforms, still have the same problem of the double spend. And so we need something to exist which ensures that this state that we're spending, right, this $10 that I have on Ledger is actually correct. I actually own that money, and I can actually spend that money. So instead of mining, which is what most people are accustomed to with the Bitcoin, Ethereum style platforms, right, where we solve the really hard math problem in order to put the block on the chain that everyone's aware of, we can't do that because there is no singular block, there is no singular chain. So what happens is that with every single transaction in Corda, there's something called the consensus service, or AKA the Notary, and that Notary will keep track of what states have been spent at the network level to ensure that Alice or Bob aren't actually double spending assets.
Okay, just to understand here the role of the Notary, when you set up the Corda network, you need to have, is it a requirement that you need to have at least one Notary?
Yes.
Okay.
Every transaction must have a Notary to go through, because that's the final step, is the notarization.
And typically, like, how do you select Notary? Because I mean, in a public chain, like for mining or proof of authority, there are different models, and you can pick and choose differently. So the Notary is someone that the business trusts. Like what would be a criteria? Like, how do you select a Notary?
Yeah, that's a great question. So honestly, it's much more of a business question than it is a technical question. So from a business side, it's who do you trust, right? If because privacy is the number one feature of Corda, you're including a third party in your transaction, right? And all of a sudden you're exposing the existence of your transaction. If not, you're not exposing the data per se, but you're exposing the existence. It needs to be someone that you trust, or potentially a lot of our customers are actually even running their own notaries at this point as well.
So when they run their own Notary, that means that they verify themselves, and then so I mean, let's say the transaction going back to the example of Alice and Bob. When the Alice sending a transaction to Bob, the Bob will basically verify that. Is that also a role of Notary, or is something different?
Well, ideally, neither Alice or Bob are running the Notary. So ideally, what's actually happening here is someone is providing the Corda application, right? So what we have another term which is called business networks. So really, ideally, someone has built an IOU Corda application, and they're running a business network in which Alice and Bob are participating. And that way, because Alice and Bob are both biased, right? If Alice is spending $10 to repay Bob, if she notarizes it herself, she could be cheating on the money. And so what we have to do is that typically the business network operator could provide a notary to provide consensus for all of their customers in that network.
Got it. Because this was about to say next is like if both parties are doing the transaction between themselves, then their party in that transaction, so they're already biased by design, as you said, right?
Correct.
Like they're not gonna, they're definitely going to favor their own transaction. So when you, I mean, yeah, I think technically I can see, I mean, you can probably run it on a node, but from a business standpoint, I think it's pretty interesting because now you need to find someone that you trust. Like, I mean,
Correct.
there is that, extra caveat now. And it'll be interesting, like, based on your experience, like, usually how businesses get to the consensus, like, oh, this is who we trust. Is it like a government regulator entities or third-party auditors? Because this, I would imagine, this is one of the areas where DLTs play a major role. It's like taking the trust out of the equation. So how that play out? I mean,
yeah. So this is a really, I think honestly this is an open question right now, but I'll walk you through a couple of things that from a design perspective and also a future roadmap perspective on this, because I think this is a very interesting topic and really pivotal to a lot of what we're doing. So the Corda networks by design are intended to have as many notaries as we need, right? So there is no limit to who can run a notary and how many of them they can run and what types they are, really. So there could be hundreds of notaries in the distant future when Corda takes off. So what that means is that it's really up to each application and each client to actually choose which notary they use. And the other benefit of this too is that we can not only necessarily have singular parties representing a notary, but we can also be looking at some of these consensus algorithms such as RAFT and BFT, which could essentially allow multiple different parties to allow a much safer version of consensus. So this is really where we're heading with this. Right now, what we're seeing is a lot of the different business networks are all kind of running their own notaries at this point. But we're doing it in such a way that will actually enable interoperability in the future once we move to a much broader kind of notary pool composed of many different entities.
All right. And just a final thought here, is there a specific algorithm that Notary runs, like, to perform the consensus service?
So right now, no, because we don't really have a need. As in where we are today, we don't need RAFT or BFT, right? That's really when you're using multiple distrusting parties. So typically what's happened is that the people who are transacting on Corda today trust their network operator because they already have an established business relationship with them. There are contracts in place. So there is a form of business trust already there. So all the notary needs to do is simply drive consensus based upon the Corda app itself.
Yeah, and I think this is just a nature of the space itself, because there's a differentiating factor between public and the permission networks. Like, there is some sort of like semi-trust exists. Like, the party anyways. Like, it's not like you're totally pseudo-anonymous. I mean,
correct.
Because, yeah, so the idea is there that, I mean, there is an identity, the party, and then you have someone that you semi-trust.
Correct. Yeah, and actually we kind of skipped over this a little bit, but this is actually a really important part of Corda, which is that, you know exactly who you're dealing with. You're not dealing with hashtag ABC123. You're dealing with Microsoft. You're dealing with Bank of America, right? You're dealing with well-understood entities. And so when things go wrong, you actually know exactly who you transacted with.
Yeah, I would imagine accountability is slightly easier because now you have a known entity rather than some node running. I think you can definitely argue pro or against it, but I think there is just a merits and demerits. I guess.
It's like in everything in software, it's all trade-offs, right?
Yeah, trade-offs,
what is the problem you're trying to solve? If you're trying to solve a very much broad worldwide thing, or if you're trying to work with anonymity, right? This is the wrong platform. But if you're solving regulated business and regulated enterprise, this is a great tool to solve their problems.
Great. I think we can spend like as much time we want, but let's try to. I will not stop you. So you want to do a demo now?
Yeah.
All right, awesome. So we're going to the demo. So
what we're looking at here is the open source site. So this is corda.net. This is a great place to get started, really. From a development side, this is where everything you need is available. So everything from how to simply set up your development environment to really more information on those key concepts I was talking about, from white papers to samples, and we'll actually dig into one of these samples here today. We have a lot of public forums which provide support. So we've got a big and growing Slack community where a lot of people post and ask questions and provide support around how to build Corda apps. We also are very active on Stack Overflow. So I think there's over 1,000 answers at this point already on Stack Overflow, mailing lists and things like that. And then there's lots of training and education. So check here to see if there's a class in your city. They really take place all around the world at this point, and everything from boot camps. Boot camps are a really good place to get connected with a quality teacher, either from R3 or from the community, and work with other developers who are just getting started on Corda.
Great. And the samples here, are we going to use one of the samples for the demo?
Yeah, definitely. So this is what we'll dig into. We have a pretty basic sample here just to get started. But to show you a little bit more, what you'll see is that the community actually has their own set of samples down here. So these are all written by non-R3 people. This is all written by people who are solving problems that were related to their development experience on Corda. And a number of really interesting things around, different languages, specific use cases, and things like that. But what we're going to stick to today is really just some basic samples that were built by R3 itself. This is in GitHub. This is the Corda organization. So this is where Corda itself is actually stored, and a number of other really interesting applications. And this is a list. It's a pretty diverse list, from basic examples applications to slightly more advanced applications, Oracle usage, Spring web servers, things like that. So there's a lot of interesting stuff here, but we're going to stick to the most basic entry one, which is simply Yo.
Yo, okay.
Yeah. And Yo is effectively a ping pong application, right? It's, hey, Yo, I'm here. There's literally no assets. There's nothing fancy about it. It's just it's the most bare bones example of Corda that exists today.
And just to like a heads up, whoever's watching this, the idea here is that we will have like a minimal setup on a dev box, send a transaction from party A to party B with a notary involved, so you get a flavor of what it is.
Right.
The basic application written in Java, because it's all based on JVM. And I think it's probably a right time to call out that all you really need to run this is basically a JVM, and if you want to write code, then probably editor.
That's right.
Yeah, that's
yep. You just need Java, and that's all I really am running here, and all the dependencies will be brought down for you and to run it. And that's actually what we'll do on my machine. Is we'll actually spin up a local host. It's just a local network, I should say, of Corda nodes to run. So let's actually do that now. I pull up my terminal here. I'm already in the samples Yo Corda app. And the very first thing we need to do is compile the application. And we'll use Gradle to do that, which is simply a task manager. So deploy nodes. And what this is going to do is go through the Java code for the Corda app and actually build out a set of nodes to run locally so that you can effectively mock a local network on your machine. And you'll see here that it's building 3 different nodes. You have party A, aka Alice, party B, Bob, as well as to our point earlier, right, I can actually run a notary on my local box. This is going to notarize transactions from my little local network. And that's that simple. It's basically its own Corda node.
Got it. So basically we got the entire network running at this point.
Yep. And in just a very much a test fashion, right? Just to develop things out. And that's it. And so we're compiled. But really, to do the more interesting thing, we need to run it. So we have a build directory, which is now created as a part of this compile step. And within it, you'll see that I actually have new directories which have the notary and both party A and party B. If you want to dig into these, I think it's actually really interesting from a deployment perspective. It's really important to understand what exists in a Corda node, right? You're going to see a bunch of different folders here, and these are all very important, and it's really critical if you're looking at this from a DevOps perspective to understand what's inside of these, right? Corda, that's the Corda jar that runs everything. Corda apps contains the applications which are running on the node. Certificates contains the public-private key pair. That is what establishes the identity as well as signs the transactions. Artemis is your message queue. That's going to be doing all the AMQP peer-to-peer message sending between different nodes.
Got it. And you can have more than one app definitely installed on a node. So right now we're having this Yo application which reside in the Corda apps.
Yes, that's right. And if you go into Corda apps, do that again. Let's just do the LL there. Yeah, it's a Yo jar. That's it.
Got it. So again, so basically that is a flow. That's a technical term. Or this is more than that.
That can be any number of things. It's a Corda app. And the Corda app can be many things. So actually, a little bit of a best practices thing. We actually, every Corda app is split into multiple jars by design. So that could be contracts and states, it could be flows, it could be other things, it could be a whole mix of things. So sometimes you could have 5, 6, 10 different apps in there, depending on kind of some of the advanced architecture stuff.
All right. And this particular case happened to be flow.
In this case, it's everything.
It's everything together. Okay.
Everything together. Your contracts, your states, your flow. It's all in there.
Okay.
Yep. And I'll actually pull up the code just to do a quick dive through of that as well after we run this. So I think the next thing to do is actually run this and give you a feel for what it looks like. Now I'm going to use something called run nodes. This is really only for development purposes. We don't actually have. You want to use your own setup if you ever run this again in the future. So this is just something to test things out. And what it's going to do is go through and start up a node for each one of these parties as well as their corresponding web servers. Now it looks like actually I lost one. Sometimes it's a little bit flaky, so just bear with me here. I'm going to restart this real quick. I'm going to just try that one more time. This is also why I don't use this in production. It's because this is not. I'd much prefer to use something like Docker when compose and actually run a series of containers as opposed to this version of the script.
Yeah, and I mean you can just create like a Docker compose file, and you can hand it over to someone running like Windows or just version of Linux and just work.
Exactly.
Because you can run Linux containers or Windows too, so. Nothing is stopping you from doing that.
Correct. It's actually, I prefer to frankly use Docker, and we're seeing a lot of uptake in the community around it. It's a nice thin layer around this that takes away some of the management, that everything's just pre-built, right? You dump your jars in there, you open up the right ports. It's not that much. And within Corda 4, we'll actually have built-in support for Docker as a first-class citizen going forward.
Great.
Cool. So what we see here is that we're going to see a few Corda nodes up and running. One of my favorite parts of this, of course, is the favorite feature of open source Corda is the jokes. So what you can buy for $1 these days is absolute nonsense. Yeah. Oh, thanks for the laugh. I appreciate that.
So this is okay. So I was about to say like, can we contribute to the jokes?
Sure. Yeah. Make a pull request. We do take the pull. I shouldn't say we. The Corda it's a lot of it's pull requests. So feel free to contribute your terrible enterprise jokes. As you can see, the bar is really low. So don't sweat it too much.
Yeah, I just feel that asking people internet to provide jokes will be a vast majority will need to be filtered out.
Yeah. Be careful what you wish for. It's kind of one of those things. Yeah. But yeah, it's just at least entertaining when you first bring up the nodes. And so what you'll see is we have a bunch of nodes. So in this case, this is the Notary node. We also have a party A, and we have a party B. And I'm not actually in my machine anymore per se. I'm actually inside of the Corda node. Each Corda node actually has its own command line interface. So now inside of here, there's all sorts of interesting things I can do. I'm not going to actually go through these one by one per se, but this is it's a great way to help manage a node if you're looking at this from an administrative perspective. What I'm more interested in doing at this point is actually initiating a flow between two parties. So a couple things. So I think the way to do that, if I scroll down some of the docs here, you'll see that we can use this command line interface to actually trigger a flow between party A and party B. So I'm going to use the flow command to start a flow. And that flow in particular is named YoFlow. And the target is going to be party B. Now, party B is simply the one counterparty. So what we're going to do is this is going to actually initiate a flow, go through all the steps to actually getting a Yo state signed, verified, and recorded to everyone's ledger.
Got it. So this is essentially what we discussed earlier on, where we have Alice and Bob doing a transaction with the notaries, doing the validation.
Yep.
In this particular case, it's party A and party B. It's essentially a similar setup.
That's right.
With the actual code.
Yep, that's right. So and if we actually run it, you'll actually get a good feel for what's actually being done. Now, this is all done, all these check marks and these things are from what's called the progress tracker, which you'll see when you get into the code. And these are the steps, right? So we create a transaction for a Yo, that ping. We verify it. I'm not sure why there's two, but we verify it with the contract. The Yo gets then sent to party B. Party B will then do its own verification. It will also sign the Yo and then send it back to party A. And then once party A and B have signed the Yo, at that point we're ready to go to the notary to have the notary sign it as well. So in the end, once everyone's done, we're going to have a Yo transaction to create a Yo, and it's signed by party A, party B, and the notary. and that finally, at that very last step, we then broadcast that fully signed transaction to every node, and it is recorded into their vaults as that immutable piece of history.
Got it. So this is sort of like a basic canonical workflow. It's basic but fully functional. It's on a dev box.
Yeah, exactly.
Okay.
The only thing that's missing is business. Just add business use case.
Yeah, that's true. So I do have one question though, because this is what I get quite a bit is, so this is good from a development standpoint, but now if you wanted to talk to someone like a business analyst or a solution architect who work with the business side of the house too, maybe technical, maybe not, maybe semi-technical, is there a toolkit for them to draw like this visually a workflow and then get some sort of like a, not a code behind, but something that they can pass it to the developers?
Yeah, so what you're getting at, right, is this is pretty technical stuff, and having a business analyst think in terms of a core app might be a bit of a challenge. And so what we typically do, this happens all the time, right? When we go to a client for the first time, the first thing we have to do is explain the business use case to us, right? Help us map whatever you're trying to solve to the technology, right? Because the technology is very flexible, so we just have to map it across. So similar to kind of like a Visio style solution, we have something called the Corda common model notation, which looks something like this. This is probably fairly familiar to a lot of folks, where you have the states represented here as these white boxes, and then you transition between states as a flow. So these arrows kind of represent the flow, and then there's certain contracts and signing constraints which are also mentioned. But this is kind of how we think about things, so that a business analyst can think in terms of Corda, and it maps very nicely to the development of the application.
All right, and this seems similar to like a UML type diagram. So
Totally.
Mostly there are tools available that you can go ahead and use them, like a Visio maybe or some other tool, and then once you have this, you can probably take this and like from here you can start having a developer working on it.
Yeah.
And this one is particularly for a specific workflow, I believe.
Yeah, so this is a basic, we work with IOUs a lot because funny enough, most business use cases are a variation of an IOU. So this is some sort of an agreement between a buyer and seller up to the point that having a deal either confirmed or canceled. Yeah, but this is just an example. But I do use this stuff to work with clients to kind of map out their things.
Awesome, great.
So yeah, so that now that we've done this transaction, though, I think would be maybe a quick look at the code as well. This code is all open source and publicly available, of course. So I'm just pulling up IntelliJ. Just happens to be the development environment I use. And within here, within the Yo Corda app, up here, you'll see that we have one class. So we actually embedded all this code exists in one tiny little class called Yo, and that's it. So what you'll see here, and I won't go into too crazy of a detail with this, but that Yo flow that we initiated, here it is, right? So that Yo flow that I wrote in the command line, it means it's triggering this flow here, and the actual code that does the transaction creation and the exchange between party A and party B is this. That's all the code. So the applications remain somewhat small. They're never really they're never the hard part of doing this. It's actually pretty, we see teams very successful in getting applications going. Really, a lot of the difficulty right now that we're really working to make easier and easier is really the deployment to production. That's all of our energy is focused around that. Because as you can see, there's not a lot of code that needs to be written on an application by application basis. Just to go one level deeper, you'll see things like notary selection. So we specify which notary in the network we use. You're actually building a state. So here's the Yo state. We're selecting the correct Yo contract, and then we're assembling a transaction with the transaction builder, which is the one that will be exchanged across the network. And once you've done that, that's really your business logic. All you have to do is sign it, as we talked about, verify it, and simply this finality flow takes care of all the exchange of the rest of it.
Got it. And from this point, basically, this flow is packaged as a jar. And I mean, we're probably not going to go in detail today in putting it into production or operationalizing it. But the idea is that's the second piece of it. Like, you test it out locally and then staging and whatnot. And from there, you go ahead.
Correct.
That's great. So let's do this. Thanks for the demo. So now we can probably talk about some of the other stuff. I think we can talk about what's coming up, where Corda is heading. So Corda 4 is next big thing in the pipeline.
Imminent. Hopefully, yes.
Hopefully.
So, but you know how it is with engineering. It's ready when it's ready.
Yeah.
Which I'm okay with because that increases the quality. But yeah, anyway, so this is the next major release that should be coming out any day now. And this is going to contain a lot of stability and a lot of improvements. Our last release was the summer, was Corda Enterprise 3. And what's coming now is a lot of really additional use case needs around this. So it's things that we've seen that are gaps in the applications from a business perspective. For example, reference dates here, right? You can see this is our release notes page. This is where you can look ahead at what's coming out in Corda 4. It's simply the same page, docs.corda.net/head. And it contains information on what the different features are. And you can see there's a lot of stuff here, but I'll highlight just a couple of which are probably most interesting. So the first one here is reference states up on this line. And reference states are basically the idea that you can include states in a transaction, but not consume them, right? So if you ever need to point to some piece of historical information in a transaction, this is a way to do it, right? And as you can see, these are more advanced topics, right? But they're very relevant for people who are building kind of those more advanced use cases. We're also doing a lot of work around stability of the network. We didn't talk much about the network today, but things like signature constraints, which have to do with how your contracts are actually whitelisted at the network level, are really important. Target versions of the application is something very similar you might imagine to like the Android world, right? Where you can target specific operating systems of Android, et cetera, et cetera. So really a lot of this is stuff that as a beginner, you wouldn't necessarily notice these things, but these are really important for the advanced application usage around Corda. Additionally, there's a lot of administrative capabilities which are being added. The ability to really upgrade and update Corda apps is really important because this is really the first wave of, going from Corda 3 to Corda 4 is the first big upgrade cycle for a lot of folks. So a lot of support around that is very important and upcoming as well.
All right, so this is basically all 2019, like this year, sometime this year.
Oh, actually, as in like probably sometime this month. I mean, don't.
Oh, really? Okay.
Yeah. It's literally imminent.
Okay, that sounds great. So, for someone, I think you show a little bit of that resources webpage early on, but this is all open source. Like, I mean, I can go here, and I think this is the Corda Git, and I can look into it. Like, I mean, this is where the actual Corda source is.
Exactly. Yeah, and if you want to try this out, the snapshot, I can't remember which release candidate we're on right now, but all the release candidates are here. This is all readily available.
Okay. Now, a little bit broader question now, since we're talking about the source base. So this is something that anyone can basically run on their own if they want to. Like,
yes.
For example, if there's a customer wanted to run it, they can just download it. They just need to have expertise. But if someone wanted to use, like Corda to do it for them or run for them, you provide that features. That's where your enterprise SKU come in.
So enterprise is really much more around functionality as opposed to actually running it. So I think we're going to be leaning a lot on partners, actually, even like yourselves, to actually do a lot of that, to really provide a lot of the services and the infrastructure around actually running the applications themselves. Enterprise is really about ensuring that enterprises are comfortable putting Corda nodes in their data centers, right? Disaster recovery, high availability, performance, long-term support, et cetera, et cetera. It's more things like that which really come with the enterprise capabilities.
Got it. But in terms of the code that is running, is there any difference that if like, I mean, in terms of the actual code base, it's the same?
It is pretty much the same. So this is a really important thing. So Corda itself is actually the core. Right, and enterprise is simply a wrapper around it. It's an extra set of features. So the core capabilities of Corda really are what's exactly in open source. And the idea is that anyone, if you so choose, you can run open source as a production application. That there's nothing to stop you from doing that. And in fact, we imagine that the Corda network that exists will be composed of many open source applications alongside the enterprise ones. And so as such, those two code bases actually know how to speak to one another. So there's complete interoperability between both open source and enterprise.
Awesome.
And I have customers who run mixed networks. They run both open source and enterprise nodes even with their customer base.
Okay. Makes sense. anything else you want to talk about or plug in?
Oh,
This is
how
the
much
right-
time you got? I can talk about this all day. No, this is good. I think this is plenty. This is really a good introduction on this, right? This is the world view from a very high level, and I think as you get into it, jump into the community things. There's a lot of depth here. It's a really interesting problem space with the blockchain stuff, and it's a lot of really cool technology. At least I get really excited by it every day. So
Yeah, I think anyone who's watching this just probably just going to the Git page, and there's this section useful links. They can get started based on where they are in terms of technically and where they wanted to get started with R3 Corda. Thanks, Austin, and hopefully we'll come back and we can talk about a little bit more deeper stuff, like maybe Notary, something like that.
sure.
But I think this is great conversation.
DevOps, and yeah, I mean, there's so many topics here. This is a lot of fun though. But yeah, thanks for having me in, Rosie.
Thank you.